Live from Soho, New York City, it's Wearable Electronics with Becky Stern.
Hi, I'm Becky Stern, and welcome to our show. Each week, we're going to talk about wearable electronics, show you cool projects, components you can use to make your own wearable electronics, and answer your questions.
That's right.
What's on today's show, Phil?
On today's show, lots of fun stuff. First up, the discount code for today. The discount code is Neopixel because the component of the week is Neopixel. Use the code Neopixel on checkout, 10% off all things in stock in the wearables and Flora category at Adafruit.com. We'll go over Wearable Wednesday, some fun and amazing things from the world of wearables. Component of the week, remember we were just talking about that. Component of the week, something from the world of wearables that we use as a component here at Adafruit and beyond. Material Spotlight, an interesting material that's used in wearable electronics. Becky or someone from the wearable community will talk all about it. We'll answer your questions. And, as promised, we're going to give away something. This week we're giving away a Flora. That's right. Made here in New York City.
On our pick and place machine and solder reflow oven.
Yeah.
If you would like to enter a giveaway, all you have to do is ask us wearable electronics questions. Half the show is dedicated to answering your questions all about wearables, techniques, where to find supplies, what to do. So ask your questions anywhere you'd like, in the YouTube comments, on Google+, on Twitter, on Facebook, in our blog comments, and if your question is featured, you'll be entered in the giveaway. So we only, we answer a couple questions. It's a pretty good chance of winning if you ask a good question.
Yeah.
So.
Did a lot of questions come in this week?
Yeah, a lot of questions came in this week.
I already knew the answer to that, but I thought I'd ask anyways.
So, yeah,
do you think we should ever do a little hashtag for questions, or should we leave it all for questions, or?
I mean, it's all right. We look at all of those different places for them anyway, so I mean, it's fine. On our Adafruit Google Plus page, or
Yeah, people are really good because you have your Twitter account and you have your own stuff, so people call it to your attention.
They do
also
both.
They do
both.
both.
Me and Adafruit, and that helps because I'm checking that.
The questions are really good this week, by the way. Very good.
So stay tuned for the questions in a little bit. You want to just dive right in?
Yeah, we're going to dive right in.
So this Wearable Wednesday and every Wearable Wednesday, we post up really cool projects on the Adafruit blog and try to bring you the flashiest, most fashion-forward, useful, and customer projects that we see online. And so this week, we just have a few I wanted to tell you about. There's a lot of blog posts, but these are my favorites this week.
Yeah, so anyone can see these on the blog today too, right?
Yep.
Okay.
And the links to everything that you're going to see today is in the description, the YouTube box below.
That's great. Okay, what is this?
This is a twittering dress. It's like a sash made from a dressable LED strip, and it hooks up to Twitter. And on our blog, you can watch their making of video, and then another video about this project. It's by a Swedish team, and so the video's in Swedish, but you get the impression. You can get what's going on. It's prints out tweets across your chest in LEDs, which I thought was quite beautiful. And it uses a bunch of Adafruit components. And one of the team members who wrote in to tell us about the project thanked us for our customer service.
If two people show up at a party with the same dress, is that a retweet, or like, well, how does that work? I don't understand.
The same Twitter dress?
Yeah. I can't believe you made the same Twitter dress as me. I retweeted. Okay.
If they're operating on different hashtags, then they should look different from each other, right? But who knows?
All right. Next up, this was a neat one. This one is making the rounds right now too.
Right, it's Iris Van Herpen's new fashion line made with magnets. So she's kind of this, out there, avant-garde, haute couture fashion designer who works with, a lot of really interesting people, makes costumes for Lady Gaga, like that kind of thing. And her this creation over here is a dress made with the help of magnets. So it's got like an epoxy filled with iron filings, and then they use magnets to kind of like texturize the surface, pull pieces out here and there, and thought it was really interesting. So it's not electronics, but it is wearable tech. She uses 3D printed shoes and like all kinds of really beautiful, cutting edge avant-garde fashion.
There was a reboot of, I think it was Twilight Zone or Outer Limits, and a meteor hit, and these two kids, they were nerdy kids, and they both got magnetized, and during the whole thing they were getting pulled towards each other. So this is the opposite. This is high fashion that you're going to get pulled towards.
And it's pointy. Yeah, don't get pulled towards it. It's pointy. I don't think the dress itself is magnetic anymore. But
I wanted to make a pincushion jacket, so the closer you got to me, the more it hurt.
Oh.
It's funny. It's a good Morrissey song too.
Yeah.
Okay. Next up.
And then my friend Hannah Perner Wilson made this necklace. She's been working on this circuit with a couple of her colleagues. That's like an auto-reactive, easy-to-hook-up LED circuit, and you can see it there on the necklace. So each of the connectors are a bus for power and ground for LEDs, and then the microphone will at various frequencies trigger the different buses. So you can watch. There's a video on the blog post of this necklace, how like when she plays different music, the lights react differently, and it uses like cut out conductive fabric, and I thought the design was very lovely.
That's great. Okay, and then next up,
we're gonna dive right into debuting this week's special project. So I don't want to spoil it. Why don't we just play the video?
Yeah, this is a project in the making, and we'll talk about it after the video. But it took a while because there's lots of different things that we have plans within plans.
Take it away.
Here we go.
Just like the music we listen to, our headphones can be an expression of our personal style. And we found the perfect pair to mod. White, translucent plastic with plenty of space inside to spare. And today I'm going to show you how to add some sweet animated lights to these Skull Candy headphones with Flora, Adafruit's wearable electronics platform. First, carefully take apart one of the earphones. Adafruit's mini screwdriver set comes in handy for this, and we store all of the loose parts safely together until we need them again later. We used 7 Flora Neopixels arranged and free-wired in a circle to fill the translucent plastic earphone with light, but you could easily use one of our new Neopixel rings instead. Drill a hole in each earphone for a wire to connect between them. We also installed a power switch through one of these holes, since Flora's onboard switch will be hidden inside the earphone, along with the tiny LiPoly battery. You can grab the code and follow our complete tutorial on learn.adafruit.com to build your own LED headphones.
Okay, and we're back.
So that's this week's project.
Yeah.
As I said in the video, you can learn how to make it at the link in the description below on the learning system.
Yeah.
And it was really fun to build. I have them here. I don't know that you can see them super well on the with our lights that we have.
Yeah, you can see them.
So they're fun. So if you have any questions about these, I can answer them next week. Just post them up in the comments.
Yeah, the neat thing about these headphones, so headphones have a trend now. It's big headphones.
Big headphones, little MP3 player.
Little tiny MP3 players, but there's a lot of space inside these headphones.
These, yeah.
And so we were able to add electronics, a switch. You can do a lot more with this.
I thought, so I opened them up, and if I had this project to do over again, you can see that the headphone jack comes in on one side over here, which means there's a little like circuit board on this side that handles the jack, and then there's a wire that runs to the other side. And I put Flora in the Flora and the battery in the same compartment, and like it's a little squished in this side, and there's a lot of room in this side.
Yeah.
So if I had it to do over again, I think I would put the bulk of the electronics in the empty one. But what there is still room for that we just didn't want to cram into that one earphone was that if you want to add an audio amplifier board to this project, you can make the headphone lights audio reactive. Yeah. And so, I want to, whenever we're making projects, we're brainstorming and like feature creep in the best way. We're always thinking of like, oh, this project could do this, 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 and this, and like at some point we need to like rein it in and have it be like, okay, these are the light up headphones, and then
so we have to give everybody else something to do.
Right. Exactly. We need to give you a challenge. So intrepid souls out there, I will be very pleased if someone did an audio reactive glowing headphones project.
Yeah, I'm going to call it right now. We will for sure see Beats specifically do audio reactive LED headphones. So they have their like massive showroom, like flagship store here in Soho.
All right, well, let's keep an eye out for it.
We could walk in there today and they might not let us out. They might put us in the back and make us, more headphones, more headphones. I think it's going to happen because it's such a powerful thing that you can express your music that you're listening on the inside to the world. Because like right now it's fun to blast music and everyone kind of hears it. Now imagine if it was like,
that would be super cool,
lights.
Right? Yeah, I once saw these guys on the subway who were having this conversation about wearable tech that was really funny. These two like homeboys on the subway, and the guy was like, "Hey, you ever notice how like music players Discman used to be real big, the headphones were real little, and how now like music players are real tiny and the headphones are real big?" And I didn't want to interrupt their conversation, but I was totally like,
"You filing away?
Hell yeah, man!" Like,
hopefully they're watching.
Maybe.
Yeah, they'll be like, "I saw this weird girl staring at us when we were talking about electronic stuff." All right. Okay, here we go. Moving right along.
So along those lines, you saw that we
used
the Flora Neopixels to make the headphones, and so that's why they're this week's component of the week. And I don't know about you, but I've got Neopixel fever.
Yeah, so we're buying these by the hundreds of thousands now, the chips.
They're amazing.
And our pick and place machine can crank out all these things. One of the things that's coming up soon is we're going to have the ultimate Neopixel guide. So the new 8x8, which I think we did a sneak preview on the blog and on Asking Engineers. It's not out yet, don't ask. There's going to be a guide for all things Neopixel.
So for those of you who don't know, they're like an RGB LED, which is a tricolor LED, which means it can display like any color you want. And it has a special chip inside the LED, actually. It's so tiny. You can see it in the center there. That helps it, is like an LED driver chip that makes it addressable. So you can chain these along in a long line where they all share power and ground, and then the data connection is bridged between each pixel, making like a giant strand, kind of like Christmas lights, but each one has a number. So you can, in your Arduino code, say like, okay, make a gradient across all of these LEDs, make them display my Twitter hashtag, make them display a volume meter. And that's really kind of revolutionary. Before these Neopixels, they're like, you have to do all kinds of crazy power driving to get even like a whole ton of LEDs to light up at once. Yeah. Never mind making them change color individually. And so especially with conductive thread, the limited number of wire connections you have to make these really easy and fun to build projects with. And of course, then we have lots of code. So we can just go through the different projects. So this is a shot from the Suspenders project, Pixel Suspenders, where they show Pac-Man animation. And then this is the Chameleon Scarf. In both of these, you can see how the ribbon technique we've developed like helps have a nice power and ground bus and then data in the middle. Yeah. And then here they are along a necktie that we use to make a volume meter tie with our Adafruit microphone amplifier breakout up top. Yeah. There's Colin modeling it.
That's great.
So these are really fun and easy. Like it's easy to make a really impressive effect, which is a really fun thing
about them.
And
then you have two more things here. This is
a heart rate sensing badge. So we like to, you can see here how I've diffused it under fabric too. It's like under a layer of this shirt. And then this is from the Sparkle Skirt tutorial, showing how to sew them in with conductive thread.
Okay. Well, once again, the code for this week is Neopixel.
Use the code to get some Neopixels. 10% off until 11:59 tonight, Eastern time.
And that's Neopixel. Got to zoom in there. All right, next up. Material spotlight. Yeah, all right. Material, get in the spotlight. What is this?
It's stainless steel conductive fiber. So it's the stuff that our stainless steel conductive thread is made out of. Stainless steel in a fiber, and it's just loose like a roving, so it's kind of great for felting. And so we've used it before to make controller pads for Makey, and that's the video clip I wanted to show you guys today, was how to get started using this material to make touch buttons for the Makey or any resistive or capacitive touch sensing circuit.
And this is a banana-like device.
It's a banana. Well, the Makey's like official fruit is the banana, so I made a banana controller for the Makey, and we have a little video to show you to outline how you work with it, because it's weird if you've never heard of felting before. Here you're about to learn.
To start needle felting, you'll need a piece of soft upholstery foam, some wool roving, and for this project, your stainless steel fiber. You'll need some scissors to cut that. Felt is a matted fabric made by interlocking the scales on the fiber with these barbed felting needles. Begin with small wisps of roving laid down in an opposite pattern to give the fibers a head start on interlocking. Then grab your felting needles and gently poke over the entire surface. I learned how to needle felt from my friend Moxie, who's a great fiber artist, and we made this video together about her pinball bumper necklace, and it's a really great primer on needle felting, so definitely check that out. Once you've got a nice base started, you can form it into a 3D object by just rolling it up and keep on poking and adding fiber until it turns into a banana. Keep in mind that wherever you poke will get smaller and more tightly matted, so that can help you with contouring. Now it's time to make the button pads, and a little of this stainless steel fiber goes a long way, so pull off just a small wisp and tangle it up to get ready for felting. Decide where you want your button and start felting it onto your object. It may look like a mess now, but remember that it'll only be affixed where you make your pokes. When you've got your basic shape, you can capture those loose wisps by twisting your felting needle around and making pokes to attach them into the rest of your button pad. Apply more metal fiber where you want more buttons to be, but be careful not to short the buttons together by accidentally felting through to another button. Pull out your Makey and clip the alligator clips to your felt buttons. Now it's time to make some music. Here's Tom to try it out.
All right, and that was component of the week.
I hope you liked it. If you have a request for an upcoming component of the week, please leave us a comment.
What other components do you think? I'm sorry, materials.
Oh, sorry, material spotlight.
Yeah. What other type of materials do you think we might see in the future?
Well, we'll do all of the weird conductive materials that we have, like Velostat and conductive fabric and conductive ribbon. But I think that we could also start to explore some other weird.
Yeah, like we have the conductive rubber stuff. We have ITO.
ITO is a good one. Yeah, like I mean, whatever. And it doesn't have to be. I think we'll go through all of the things that we carry, but then we'll also we get samples of stuff all the time that investigate cool materials.
So it'll be like America's top material we could do.
Sure. Yeah. I mean, I think maybe we'll also do some non-electronic stuff, right? Like telling the difference between different kinds of fabrics.
Yeah.
That's something that a lot of people need help with. Like, how do I?
So what's this over here? You have something that you're working on.
Is it like? Am I basking in an LED glow, or is that am I just flushed?
Yeah, I don't think you were turning purple. Breathe, Becky, breathe.
So today the component of the week is Neopixels, and so we wanted to show you a sneak peek of something that we're working on. It's just an experiment.
Look at all these LEDs.
It's a textile pixel matrix, and so we're working on putting like 150 LEDs, but for now there's just 3 rows of 19, and then the top row's not connected yet. And my lovely wearables assistant, Rissa Rose, has been helping make this very large sewn pixel grid just to see how far we can push it.
Yeah.
It looks cool also if I diffuse it through this.
Yeah, the origin of Flora is the end result is going to be a wearable jacket, and you wear a movie, specifically Blade Runner.
Blade Runner specifically.
Yeah. So that's how products come out of Adafruit.
I don't know what I did. I diffused it, and then something really exciting happened.
Yeah, you can put your hands over it. It does look great.
So we're working on making a big pixel matrix. So lots of you ask me all the time, like, oh, I want to make a jacket with covered in Neopixels, and but I don't have any sewing experience. Well, I'll tell you that we're trying right now, and it's not the easiest thing to do. So, as you can see,
that's great stuff.
Cool. Yeah. Anyway, we could leave it up. Well, I don't know if we have little us while we answer questions. Whatever. We're going to answer questions now. It's Q&A time. Remember, if you ask a question featured on Wearable Electronics with Becky Stern, you will be entered to win a delightful giveaway. Today's winner will receive a Flora main board.
That's right.
And it'll be a random drawing between the questions that we feature today.
Yeah. Okay, let's jump right into the questions.
Yeah, sure.
All right, the first question for you, Becky, is I tried wiring up the Neopixel ring to the Flora, and my laptop shut off the USB port saying it was drawing too much power. I tried to power the Flora ring plus 3 AAA batteries, and the board shut off. Why is that?
My guess with this guy is that he forgot that there's a switch on the Flora. So this happens a lot, and it's gotten me before when
there's a switch.
Flora is always powered when you plug it in via USB, as it is here with the Pixel Matrix, and then when you disconnect USB and you plug in the battery is actually controlled by the tiny little on-off switch on board, which is really convenient because when you're plugging in USB, you always want it powered to program it or whatever, and then you want to be able to turn it on and off. So I'm guessing that's this guy's problem. If you have it on and it's not turning on in battery power, you've probably got a short or something else wrong. But the 16 Neopixels at full brightness can overload your USB port.
Yeah, it's kind of like a motor. When you run a motor through an Arduino, that can do that. Same type of thing. It's
current draw. Yeah. So your USB port has limited current, but I think he understood that. I think the switch on the board is
okay. Next up, this is from Caleb. Can you bridge embroidered lines with your fingers?
Sure. So embroidery is a great interface by which to make like a tactile interface or something. You can make buttons and pads and then sense when your body is bridging a connection. But you probably do capacitive touch sensing. You're not going to run current through your hand, but you can detect when you've shorted out or the resistance drops considerably between two lines of conductor thread in an embroidery. It's actually quite nice. Although, touching embroidery is very nice, but if you have it in a public place, then it's just going to get dirty really quick.
Caleb, former editor of Hackaday, now at EE Times, asking the tough questions. Next up, Ben Gray says, what are the options for powering wearables, in particular Neopixels, which can be quite juicy and also run on 5 volt? I've not had much success with the LiPos thus far.
It's funny because I've had great success with the LiPoly batteries. The thing about them is that they're 3.7 volts. They're not. So the Neopixels can run, their optimal voltage is 5, but right now, oh no, this is on USB right now, but when they're on 3 volts, they're usually a tiny bit less blinding, which is great for me. And then you have a large amount of power at the same time, a large amount of current draw at the same time. So this is what we were using to power that thing when it's...
it's a beefy battery.
Yeah, I mean, it's a 20 I don't remember how many milliamp hours this is, but a lot, maybe 2600-ish. Don't quote me. And it's 3.7 volts, so when it's fully charged, it like makes the Neopixels really bright. What happens is if the battery dies, the voltage can drop, and like you can start to, like, if a conductive thread connection was kind of flaky, but it was being overcome by the forward voltage, like you can see your circuit will start to get flakier the more the battery dies. But just like charge up your battery, and then you can also put multiple batteries in your circuit, like just splice into the power and ground buses. That's what we're going to have to do on this big textile matrix, so that you're splitting the current draw load between multiple li-poly batteries. And I've had great luck with that, and they're my go-to. I mean, yes, they're a little bit dangerous. You should read the safety warnings, but they're really good.
Yeah, it's a concentrated form of power in a tiny area.
Yeah.
Also called batteries or bombs. Same thing.
Right.
Okay. Next up. This is from Mano. Dear Becky, my question, how do you use conductive thread in stretchy fabric without tearing when it gets stretched? I mean, when you sew it into a tight skirt, and then when you put it on, the fabric will stretch, but the thread won't.
That is correct. And I haven't met an elastic conductive thread yet, and that's because when things stretch, they they move, right? And movement is hard for electricity. So what I have seen that solves this particular issue is stretchy conductive fabric, which we do have and does exist, that's been like laser cut in a little like zigzaggy pattern, so that when it's stretched, the conductor just like pulls apart a little bit. The conductive thread that we have won't tear. If you sew it into a spandex skirt and you put it on, it's just not going to fit. It won't actually tear the thread because it's made out of metal.
Little tiny cables,
Yeah, so like it'll cut. The thought of like breaking it with your hand actually hurts my mind, like, because it would hurt your hands. But so if you want to sew, like, you could use conductive fabric in a zigzaggy way if you really need it to be on the external of the thing, or like try to sew the circuit into the seam, or have it on a floating wire structure that's underneath the spandex skirt. Like, stretchy fabrics are really tough and not for beginners in wearables because they're like there's some but those are my tips.
Okay. Next up, this is from Mike. I'm looking to interface a floor on a t-shirt with one Neopixel on a hat. I cannot collocate them in a project. I was looking to use the Adafruit 4 conductive ribbon to go from the floor onto the shirt to the Neopixel hat. What would be the best solution? Thank you.
Best is hard to say, but that sounds fine. We have two different four conductor ribbons. One is a piece of black kind of nylon with 4 insulated stranded wires inside it, and it's kind of holds its shape when you bend it, and that's pretty good. That would work fine for this project. The other one is a conductive thread 4 conductor ribbon cable that's much more flexible, and the conductive thread traces are insulated from each other, so if it folds over on itself, it doesn't short out. That is made with silver conductive thread, which does oxidize over time, but it's much more flexible and would give you like a really stealth little thing if you really needed to put the circuit down on the shirt. Although if you use one of our tiny batteries, I don't see why you couldn't put the whole circuit on your hat. Anyway, that wasn't what the question was. So, I would also look into, one of my favorite things are those like coily phone cables that like Secret Service dudes wear.
Yeah.
And then down your shirt, because like think about it, you don't want to reinvent the wheel. Like, think about everybody else who's had to do the thing where they run a wire from their head to their shirt or their belt.
Yeah, someone has solved this.
Someone has solved it. Look it up and reappropriate their cables. I mean, you could also just use a very thin wire, like a headphone cable, or So like, think about all your options before you decide you need to do it with conductive thread.
All right, more questions rolling in.
Yeah.
Becky, I'd like to know how to make fake skin with embedded electronics for skin wearable projects with a Flora controller.
Me too. I want to do this for Halloween.
It's almost Halloween time.
I would like to try it.
Yeah, there is that fake putty skin stuff that does dry. It's almost like flesh-colored Sugru.
Sure. So there's like liquid latex, and there's like silicone makeup prosthetic stuff that you can use to make. I think that Make did a video recently about some fake makeup stuff that you could do, like wounds, where you like take a sheet of plastic and you form the silicone or the liquid latex on it, and at that point you could also embed your electronics. So for this guy, I would recommend that you like make your circuit with really thin wires, test it out, make sure it's working, then go into your special effects makeup stuff and like embed it in the liquid latex or silicone thing, and then when you put it on your body, it'll be there. And that's what I would like to try, and I think it would work and be cool.
It's almost Halloween time, so this year is the first year where there's a lot of easy-to-use wearable electronics. So I'm totally expecting Flora to be inside of every possible thing.
It's really small, so like head-mounted stuff is really easy.
And LEDs can shine through all this costuming stuff, so really, it's going to be a really fun Halloween.
I think maybe I want to be Borg, but that's a little ambitious.
Well, just time. Next up, How do you protect wearable electronics from static discharge?
I've
That's
never
from
had a
Gert.
problem with static discharge. Like I've never been, I guess, granted, I don't have carpet. So like in any
Yeah.
of the places I ever go. So I don't like walk around with my wearables and then get shocked. But
Yeah.
it's never been I've never had a thing go bad because of static discharge in my
Yeah.
entire electronics career ever.
Yeah, we'll probably see this year what type of things. I mean, Flora's been out for a while. Wearable electronics has been out for a while.
Yeah.
I haven't, and I read every single support inquiry
Yeah.
coming into Adafruit. I haven't heard of a single person ever having a wearable electronic thing that we sell get zorked because of static.
Yeah. So I mean, so while it's a concern and we ship all of our stuff in anti-static bags because you never know what happens to packages when
Yeah.
they're in transit or whatever. Personally, I've never been a concern
Yeah.
of mine really. But I have a static dissipative desk and I make sure that I'm not. I don't know.
Yeah, I always think about like what happens out in the wild and what type of returns or customer
Yeah.
inquiries. So far, nothing. So either everyone's great, or maybe these things are a little bit more robust and rugged than maybe the old days.
Sure. I mean, it
electronics.
also would depend on where the circuit got shocked, right? Because if it got shocked anywhere, like the Flora has built-in power protection, which would
Might
like
be okay.
prevent the battery from like doing anything weird because of a static shock. But you know, anyway.
Yeah. Okay, and here comes the last question. What would be the best way to interface sensors into an LED-laden wearable party outfit in order to make it react to sound level and motion, so to make it most reactive in a rave party setting? All right, Bryce,
How do I make my rave garment?
you want to make a rave suit.
That sounds great.
We want to help you.
I would love to help you. So there's two projects you should look at, and then you could probably take the code from both of them and mix them together. So the Amplify project, which we actually have a picture of, I don't know if you want to go back to it.
Yeah, we can do that.
The Amplify project has our the Adafruit Electret microphone amplifier breakout board up at the top knot. You get that. That's what gets your sound in. Then these Neopixels are reacting, and the code for that is online. Phil B wrote an excellent sketch for controlling those LEDs. And then the other project you want to look at is the Sparkle skirt, which uses the accelerometer to make the skirt twinkle the more you move around. So it's like motion dance activated skirt. So if you mash up those two programs, you're going to have your sound reactive, motion activated rave party suit.
Yeah.
And
Yeah.
please share it with us.
And also look at the twittering thing that happened.
Yeah.
The Twitter address. I mean, that's like, all these things are out there now. People do a really good job of showing how they make them. So I think putting all that stuff together to be able to do that. Please send photos and music.
Post them up in the forums.
Yeah.
And I'm going to do the giveaway now.
Okay.
right?
Yep. Next up, it is prize time. This is the prize, Flora, made here. We get to say made in New York City.
It's so cool when they roll off
Electronics.
the production line too. So I'm using the City Bike Blinky helmet as our grab bag, and I've got all of your. Caleb is not eligible, but I've got the eligible.
And neither is Ben. He's a reseller. Sorry, Ben.
Oh, sorry.
Yeah.
And then Rick just won something.
You won something on Ask an
But
Engineer.
if you don't win, submit more questions. So anyway, all eligible contestants are in this hat right now.
They're
does it
actually
look
they're-
like they're
there's
in there?
actually in the hat. They're very
Mini
tiny
can-
people.
This one. I'm gonna pick this one.
All right.
It's very unceremonious.
And the winner is
Mike on Google Plus.
okay, Mike.
Barella.
Mike Barella. Congratulations, Mike.
You win. Jan Flora.
You got a Flora.
Congratulations.
Okay. All you need to do, Mike, is email support@adafruit.com if you're watching. Otherwise, we will
I'll try to hunt you down. but-
tweet, Google, Facebook, poke, +1.
I'll Facegram you.
Yeah. Something's going to happen to you.
It involves a Flora.
And you're going to get a Flora in exchange. So.
So we hope you've enjoyed this episode of Wearable Electronics with Becky Stern. Please tune in next week at 2 p.m. Eastern, 7 p.m. most European time. And if you have suggestions, questions, want to be eligible for the giveaway, post them up in the comments at us where we can find it on Twitter, Google+, Facebook, and the YouTube comments and the Adafruit blog. And we'll see you next week.
Okay. See you next week.